Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you are amongst the 50% of the people who've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, so toss me a buck or two in there if you are enjoying these streams. But most importantly, if you would like to join the debate, with the page you are currently watching on mute, simply click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you will be ejected, and if you are, please do not try to rejoin the stream using accounts. You'll be warmly welcome back on the next stream. In a moment, I'm going to transition across to the actual Hangout, as we do have a guest waiting to present something, which is Ranty, who I'll give an introduction in a moment. But before I do, please share the show, as it does increase the live audience, of course, but that in turn increases the chances of having a more diverse panel. So please share the show. And one last time, if you're new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. And with that, I'll say my first introduction. So, how are you doing, Ranty? Good to have you here.
Yes, good to be here.
The mic's all yours, my friend. If you want to go ahead and chat away. That's fine by me. I'll put myself on mute and you can present whatever. I'll stick the camera on you so people can see what you're doing.
Okay, not a problem. Do you want me to start sharing my screen? And we shall crack on. Actually, I'm just going to load up the YouTube and get onto your screen so I can see what people are talking about. Wow, 9 thumbs down already, and I've only said hello. Okay, well, there seems to be a lot of controversy about the viewer height for Anthony Riley. And basically what I've done is I've found an Ordnance survey map that's available online. Anybody can go and check it. It's cad.uk mapcenter.com. It says here, Ordnance Survey Master Map Topography Layer is the most consistent, comprehensive, accurate digital representation of the geography of Great Britain available from a single source. It enables organisations to geographically enable business processes and underpins the nation's biggest and most complex commercial organisations and sits at the heart of central and local government policies and processes. So I think we can be quite sure that this is fairly accurate. Now, the whole thing that I'm doing here is just testing whether or not Google Earth is consistent with the Ordnance Survey of Great Britain. So what I've done here is I've gone into Whitehaven. Obviously, here's St. Bees. And I'm going to keep clicking in and clicking in until we get close enough where we can start to make things out. And we've got some values here, like 98 meters, 79 meters, 126, 141. Obviously, this is where Anthony was taking his video, in this location down here. I think I can show it you a little bit better because I have got something ready for you. Here we go. So this is basically a screen capture of the Ordnance Survey, which shows 98 meters here, 79, 126. Start coming down into the village, and you've got 21, 55, and 8. So these are all Ordnance Survey up-to-date values for this area. So what I've done is I've got another image here where I have put some untitled place marks on little pins onto Google Earth. And what I've done is I've mapped out these 3 locations here, this location on the top of the hill here, and these 3 locations here, all these that have values on. Now, this is only to see whether or not Google Earth matches the Ordnance Survey. So when we're looking over here, we're looking for values of 98, 79, and 126. So when I come into this place mark here, the first one was 98 and this one is 95. So we're 3 meters out on that one. Okay. Next, we've got 79 and 126. Here we have 80. It should have been 79, so we're a meter out. And over here to this one, 126, and it is 126. Okay. Now then, we're going to be looking for this one in the center next, top of the hill. We've got 141. Here we're going to the top of the hill. Does Google Earth match up? 140. Close enough. Next, we're going to go and check these last three values here, 21, 55, and 8. So 21, and it's 21. The next one should be 55, and it's 54. And lastly, 8, and we're down to 9. So realistically, you can say that Google Earth matches the Ordnance Survey of Great Britain. So if that's the case, when Google Earth says here that Anthony Riley was at 10 meters or 11 meters, that is exactly his elevation because it matches up to the Ordnance Survey of Great Britain.
Good stuff. So when they're fudging the figures anyway, Ranty, they're fudging them up to 100 feet for no particular reason. But they're still not being able to see the lighthouse as much as they want to lie to the audience, or Paul specifically said to the audience, we can see it, we're within 50 feet. In other words, we can't see it, it's still blocked after they fudge the figures. But as you've just demonstrated, there's no necessity to fudge the figures. It does match the Ordnance Survey map. If you take a few locations nearby, they match. So there's nothing to tell you that it would be anything other than what it says on Google. And that's what we've gone from all along. As much as the Globeheads want to change that to some increased figure for no particular reason, there's no need. It's 35 feet, like it says on Google.
That's correct. And also, there's just a question in chat. Somebody said, why don't I go to the exact location on this Ordnance Survey map? And unfortunately, it doesn't have a value for it there. It just gives values of areas, you know, topography that's easily identifiable. Basically, it matches up to Google Earth. So if Google Earth is correct and the Ordnance Survey is correct, then it stands to reason that they've got the rest of it right. I don't see why they would get it wrong. They're not going to make a difference. I mean, they said it was 100 meters, 100 feet, was it? So that would be what? That would mean Google would have to be out by 200%. And I think I've quite categorically shown there that Google is within 1% of the Ordnance Survey.
Well, the specific land that's at like 100 metres around that area. So if that particular piece of land was at 100 metres, it suddenly becomes of geological significance. You know, they'd definitely note it, but it's not. You know, it's just roughly, you know, the same as everything else around there within a metre of what it says on the Ordnance Survey map.
Now, you know, this shouldn't be contentious. You know, the ballers shouldn't really disagree with that. I mean, that's literally just taking the Ordnance Survey and just checking whether or not Google Earth matches up to the Ordnance Survey. That's a simple test that anybody can do. It's not fudging anything. It's literally just going from one place to another place and checking, do the match up, and they match up. And these are government. This is a government site that the government relies on. It says it down here. Let me read it again. Ordnance Survey Master Map Topography Layer is the most consistent, comprehensive, accurate digital representation of the geography of Great Britain available from a single source. It enables organisations to geographically enable businesses, processes, and underpins the nation's biggest and most complex commercial organisations, and sits at the heart of central and local government policies and processes. This is how respected this Ordnance Survey site is. And it matches up with Google. So I know there has been an old Ordnance Survey map that was dug up. It's nearly 100 years old. I think I would rather rely on modern day technology to tell me what the elevation is. So if the rest of the topography is correct, I would imagine that they're quite accurate when they say that it's 10 to 11 meters next to those caravans. That it has to be 100% categoric proof of the elevation.
Or at the very least, it's proof that they roughly match the model that they're using. We never seem to have any issues when it comes to the target height. Straight to Google for the target height. Anyway, we've been joined by Ali B. Good to have you here, Ali. Give you a second to unmute. Maybe he can't hear us yet. We'll give him a few seconds to figure out his sound and stuff. Hopefully we'll hear from Ali in a minute. But yeah, good presentation, Ranty. Good. Yeah, I can see you waving away there, Ali.
We've got Ron Burgundy saying the survey map said it was 20 to 25 meters. I do have, I've actually taken that old survey map and I've actually put it onto a new, onto the current Google Earth map, and it's a mile out. I mean, the 100 meters that they're specifying is probably around about 400 meters away from where Anthony Riley was actually standing. So it couldn't have been further away from the truth if they'd have tried. Even that old map was way out.
But for all the people that accuse people like yourself and Anthony of lying, on screen, you can check it yesterday, we literally had Paul lie and tell the audience we can see it, and then in the next breath say it's within 50 feet. So we can't see it. So this is the extent that the Globers are going to get around this problem of a massive amount of Earth curve being in the way of the stuff we can see. There's no Earth curve in the way, we can see it, and they're trying desperately with 100-year-old Ordnance survey maps to fudge the figures. And even when they do, we still can't see the land in their model.
Let me just present this. I'm just going to present. Let me bring this image up. Here we go. So this is the old Ordnance survey map. This is the old one. And here we have the town here, which is here. And we have the town underneath it, which is this one here. This is where Anthony Riley was standing. And I've put an X on each so we can see. And way down here, you know, is the 100-meter elevation and the 50 elevation and the 50 elevation. That is nowhere near where Anthony Riley was standing. If I go to Google Earth, I can show you roughly, this is the area that this Ordnance survey was suggesting it was. And as you can see, it's like 90, 94, 95, 96. There's 100 there. Okay. But when we follow Google Earth and we come down to the pathway and then we go all the way across, we can see that the elevation is just 9, 10, 12, 14, down to 9 again. So the survey map that they were saying was pointing to a location here, which was so far away from where Anthony Riley actually took the video. It's impossible, and they are portraying this as truth. A 100-year-old map, and they're saying that this is the location that Anthony was in. It's a joke. It really is.
Just see if Ali's got any sound yet. See if he's cracked it.
1 2 1 2.
Perfect. We can hear you beautifully. Good to have you here, Ali.
All right, Nathan. All right, Randy.
All right, Ali.
Joined by M. Scott, who is the son of an astronaut. Good to have you here.
Okay, cool.
Hey, how's it going? I have another map I wanted to put. I'm gonna put it in the side chat, and you can just bring it up on your screen share or whatever.
Yeah, ready whenever you are. Just let me know. Just give me a shout, and I'll present you. If Ranty, if you could do us a favour and click on that, just so I don't have to abandon the Hangout. You know, at all costs, I'm going to try and avoid presenting stuff for people because it means I'm no longer in the Hangout paying attention to that. But if you could click on it, or if you can, Ali, and I'll present either one of you. Presumably, M. Scott's on a mobile. Or if you can present it, M. Scott, even better. I don't know if you know how to present. Oh, there we go. We've got it up pretty quick already. Thanks, Ranty.
Okay. What are we looking for here?
So if you look where Riley was standing, doesn't that one say 33 meters where he was standing?
The P here. Yeah. See what it says? You see, it says P here. This is where Anthony Riley was. This is his location here.
You see, just the northwest of the golf course.
Yes, here. This is where my cursor is now, underneath the P.
Go right to the golf course and then move to the upper left, and you'll see there's a 33 elevation there.
Where's this? Am I going left or right?
You want to go to where the golf course is. You see the golf course?
So I'm going right, yeah?
Yep.
Now where am I going?
And then if you just go right directly to the north, right you are, just go down to the left diagonal, you'll see it says 33 right there.
Here?
Yep.
Yeah, that's consistent with Google Earth, but it's also probably about 400 meters away from where Anthony Riley was standing.
All right.
this is where
No,
you just told me to go.
Look at the golf course and just look at the numbers right around the golf course. You see the 33 right to the left and up.
Yeah, I see the 33 there, and I see the 38 there. Yeah.
Is
And
that what
yeah, so that's quite consistent with what I've just showed.
What? Isn't that 99 feet?
If I go down here, this is the golf course around here, and I go down here, we've got 70 meters.
Yeah, so 33 right there. Isn't that where he was standing?
No. Oh, he was stood here.
That's what I'm saying. That's where it says 33 on the map.
No, it doesn't. It's a mile long. Let me show you again.
When I heard Riley talk about it, he said, I can't guarantee that I know I stood this. He said, I stood between the town and the golf course, somewhere in between there. So is it anywhere in between there for a game?
No, this is where he was stood. We've triangulated it with his videos and also images that he had taken at the time. This is where he was stood here, right where the cursor is now.
So when he said that he wasn't sure, he's now figured out exactly where he was standing?
No, it's true. It was between the golf course and the caravan site. There is no doubt about that. That is exactly where he was. He was here.
Yeah. And that's what he said. That's the most I can guarantee.
No, that's where he was. Here.
Yeah. So that 33 is between the golf course and the caravan.
No, the 33 is here. That's correct. Yeah, but you're also a country mile off. That's what I'm saying. Because literally that's like over here somewhere. Where are we? Where's the 33? Where's that going to be? Around about here, I would say. 30 meters. Yeah, that's before the golf course. And he wasn't here. He wasn't here.
I guess I see now why screen sharing with somebody else is impossible.
How is it hard to understand?
Just go to the map. Just go to the map. Just go to the map. Just go to the map.
And I understand what you're saying.
No, but go to the map. I just think you're not seeing the right 33. Just go to the map.
Oh, I am seeing the right 33.
All right, let's look.
Oh, there's the 33 here.
No, but on the map.
Here.
Okay, now zoom in. Can you zoom in?
No, not on this. It's just looking on it from.
From what?
No, but yeah, it's here. There's a 33.
You see it right where your thing is?
I can.
Oh, yeah, that's the one I'm talking about. Right above the right there. Isn't that where he's standing?
No.
Why not? That's between the
I can't make him stand there. He just wasn't stood there.
We can't make your numbers fudge to where he's standing, I'm afraid. You know, you've got the location wrong.
You know, I can't make him stand.
You've got the location wrong. Simple.
He was stood here. Yeah, that's just the way it is. He was stood here, and you're saying he was stood here, but the topography of the land changes so drastically in that short distance.
I'm just confused. So is where I'm saying included in what he said of I was standing between the caravan and the golf course, somewhere in there, I can't guarantee exactly where.
Well, if we go back to the video, and he also does another video just prior to this, and it's from the same location because you get the same rock face just in the corner of your view here. So you know he's in the same location. And he does a panoramic actually, which is quite good, and he shows you the caravans right next to as we're playing the video. Anyway, here he is. This is the little cove on the corner. And if we scroll out a little bit, we're looking at this little cove here. So obviously he's facing this way. Like so. And he's looking over to the Isle of Man.
Can I just explain something though, Ranty? Sorry to interrupt. We went through all this yesterday. It does not matter if you fudge these figures to 100 feet. So it matters if you have 100 feet, then we should obscure 180 feet of the lighthouse. The lighthouse right.
Is 200
sorry. Just gotta clarify what you have just said. So we go to 100 feet, and the lighthouse is still obscured. Correct?
Partially, yeah.
Right. So what's the point of this exactly?
Because if we can see some of the lighthouse, we should expect.
No.
Okay.
No.
Okay.
You've just made it very clear that we are still 100 feet shy of seeing it. In other words, it is still obscured.
I misspoke. So let me tell you exactly what I'm trying to say. If we're at 100 feet elevation, we should see at least 33 feet of the lighthouse.
Do you want to bring up the maths, Ranty?
Yeah, sure. But let's just clarify this though for 1 minute. Can you see the topography of the land on here? Can you see that little peninsula there? Can you see the direction we're looking in?
Yep.
Yeah. Okay. That's good. Because would you say that matches up to the Google Earth here?
It could be. Although I really just trust Riley. If Riley says I was standing here, I believe him. If he just tells me exactly where he's standing. If you're saying he said right this spot, then I believe it. I just heard him say I can't guarantee a spot, so I thought that was the current best knowledge.
Yeah, well, no, honestly, that was where he was stood. If he was stood over here, I mean, you wouldn't even see that peninsula. I mean, it would be impossible to see that. If he was stood where you suggested, which was here, you know, he wouldn't be able to.
No, you're way. That's not what I'm suggesting, though.
It'd have to look that so far that way. It would be impossible. You know, when you watch the video, you can see that the Isle of Man is in that line of sight from here as he zooms in. So you can triangulate it 100%. So this is where he was stood. Anyway, so you want to do the math again? Sorry.
I don't know why Nathan want to do the math again because I guess he doesn't believe me when I say 100 feet elevation and 31 miles gives you a obscure, and you use standard refraction, you get about 100 feet obscured. 180 feet obscured.
Hold on. So we're going to be adding refraction straight away. So what
Just
I'm trying to hold on. So what I want to look at is how much of Earth is blocking our view. Let's not worry about what the light's doing. We need to see some evidence of refraction if I'm going to accept refraction. What I'm looking at is how much Earth blocks our view of the lighthouse. So let's just have a look.
Okay, so if it's 31 miles and the view feet is 35 feet.
100 feet in this case.
All right, we'll do it at 100 feet in a moment.
Okay, sure.
Well, yeah, let's do it from the actual height, which was 35 feet. Without refracted, you know, so before you include your refraction, we're looking at 376.
So far we've got a 300. How high is the lighthouse?
213.
213. Yeah, so even with refracted hidden, you shouldn't. I mean, that's just to the top of it, by the way.
At 35 feet, this is a disaster. At 35 feet, this is practically proof.
If we do it to 100 feet in height.
And it's how high? 200 and what?
213 to the top of it.
215? Did you say 215?
Yeah, about that. 215, 213.
Right, can you see where it says hidden equals 234? Can you see that?
Yeah. Yep.
Yeah, now look at the refractive standard refraction.
No.
Yeah.
Sorry. Did you hear my question? Can you hear how much Earth is blocking our view? Do you understand simple English? How much Earth is blocking our view of the lighthouse?
Without refraction, 230 something.
So you're forgetting, though, that's to the tip.
Yeah, so then with standard refraction, how much is blocking out?
But we've already given you 100 feet in viewer height.
It's not 100 feet for a start.
Just for the moment, if we assume 100 feet.
We're not going to assume 100 feet. That's why Ranty's just done a presentation. Did you not understand the presentation? Why are we fudging this maths?
I did. At 35 feet, it's absolutely very indicative that there's not the curve we expect. Like at 35 feet, this picture makes no sense. I agree with you. This is very compelling evidence if we're at 35 feet, right?
We are.
We agree with that, right?
We are at 35 feet.
Okay, I'm saying, so it's very compelling. I agree with you. But if we're going to
I want to establish that even after you fudge the maths, Earth is still blocking our view.
Say again? 180 feet of
Earth is still blocking our view at 100 feet.
No, we see 33 feet, right?
Sorry, let's just bring it up one more time for the guy who absolutely insists that refraction is occurring, even though he's presumably not going to bring up a photograph and show us any refraction in the image.
I'm assuming standard refraction, yes.
Do you want to show me some refraction evidence in the image?
Nathan, I'm not telling you I guarantee you refraction, because I'm not saying I prove to you. I'm saying, look, if we assume standard, just for talking about it.
Well, we're not going to assume anything.
I'm not trying to win it on this one point. I'm just saying, let's talk about it. If we assume standard refraction and we're at 100 feet, which is something that keeps being said, then we should see some of the layout.
Why are we assuming standard refraction? Why are we doing this?
Because it shows us that there's actually conditions which we expect are pretty normal, happen a lot, in which we should expect to see some of that lighthouse. If we're at 100 feet. Now, if we're not at 100 feet,
that's a lot of ifs. If we're at 100 feet, if we have conditions that are conducive, if. We're not at 100 feet, and
at 100 feet.
Earth is still in the way. That's the bottom line here. You want to pish gallop with refraction.
We see kind of what we expect to see, right?
What about the left-hand side of the island? The one that's 51 miles away? Because that should be under 815 feet of refracted in.
1,000-foot wall in the way.
100 feet.
One by one. I mean, I'm reacting to something I hear over and over, which is 100 feet does not help. That's not true. 100 feet actually does help. 100 feet with standard refraction means we should see some of the lighthouse.
We should see a tiny tip of the lighthouse, which is the nearest thing we can actually identify. And it's one of the closest things we can identify on the island. As we go further right in the image, we see more and more distance. So it becomes harder and harder for your accounting for stuff that's missing as we go further left in the image. So of course you're going to pick the lighthouse. It's one of the closest things. and you're going to try and fudge the maths.
I was just reacting to the statement that gets said a lot, which is not true, which is 100 feet does not help. Now, I don't know for 100 feet. I mean, Riley's really the one that knows.
Well, no, we've tried. We've just shown you. We've had a 100-year-old Ordnance survey map from the Globers to claim that it's 100 feet, and we still have Earth in the way. We then have to go into refraction to bring it back. So you're just claiming, oh, well, no. As soon as we get to 100 feet, it helps. We're bringing it back. Yeah. No, that's if you assume refraction. If you assume refraction. Yeah, but the model shows that Earth is still blocking our view. So we're into this fantasy world of refraction helping you bring things back from around the curve. Not direct line of sight. We don't have line of sight. We still don't at 100 feet.
Yeah. But to be fair, though, it's like you do accept that refraction sometimes happens, right?
I don't accept that refraction changes our line of sight. I think it's nonsense. Complete nonsense.
So you don't believe refraction at all? You think even standard refraction is a fantasy?
I think we see refraction effects in the image, and they are not as described. The refraction calculations have been co-opted purely to exaggerate curvature that does not exist. It's simple. That's why it's there.
What do you mean that's why it's there?
That's why it's there. That's why this calculation exists.
Can I just speak for a second, please? Can you read, let me see. Can you present this, Nathan? Just to show this little bit here. Can you see that?
Yeah, you're presenting.
Right. The refractivity of water vapor is less than that of air, so that if the air is moist, the refractive index will be smaller than the value calculated for dry air, which is standard refraction. This water vapor term is dependent on wavelength in the visible region of 405 to 644 nanometers. The relationship is that.
Okay.
Right, and you're multiplying it by 10 to the power of minus 10.
Okay.
Right, so there's no correlation. You have to take into the account of the water vapor, and I checked it out. It's like 95% over that stretch of water, and plus the temperature at sea level is around 1 degree, 2 degrees.
So refraction happens, right, when two mediums have different densities.
Did you just hear what I said? Did you just hear what I said?
Yeah, but it doesn't. What is the conclusion you're getting to? What is the conclusion of that?
Well, you're not taking into the account is water vapor, meaning it refracts less, meaning
what? What does that mean?
Well, meaning it wouldn't make it over the curve, matey.
It wouldn't be what?
Refracting less, lower than standard refraction.
You're saying the water vapor works against you.
That's not true.
Exactly.
It's not true, though.
There's the equation, mate.
No, that's how it works, right? So if you have two different densities, right? Light's going to travel through the densities at different speeds. So when it hits a new density, it slows down or speeds up. Based on whether it slowed down or speed up, it'll either go bending up or bending down. And look, if you guys say refraction doesn't exist, then I don't know why we've ever talked about it. If you literally don't believe refraction happens, then why has it never been mentioned? Like,
I do really believe refraction happens. You're putting words in my mouth. I can show you where the refraction occurs on the image. I can evidence it and say, here's a little tiny bit of refraction in the image. Whereas you guys just say, hold on. I can demonstrate where refraction occurs in the image. You guys tell me the entire island's a mirage with zero evidence.
No one says that.
Yes, you want to go back to yesterday's hangout and watch Paul say that. I asked him specifically. Hold on, you've just told me no one says that, and I'm telling you a physicist said it. M. Scott, can I just clarify what I've just said? Right, you've just said no one says that. A physicist said it within 24 hours of this show. He specifically was asked, how much does it refract as we go down from left to right? He said it refracts evenly and lifts the entire island up. The whole thing is looming. That's what he said. That's a physicist. No evidence for it. No evidence for this. Just an assertion after he showed us how it would work mathematically. He just asserted that the entire island was looming. That's what he asserted.
Other people asserted. You're right. I'm sorry. So I don't know what other people asserted, but he's probably wrong about that. But so then what are you trying to say, though?
I'm saying we see the entire island because the Earth is flat. There is no Earth curve obscuring our view. It is very simple.
You told me you could identify where the refraction occurs?
Yes, there is refraction in that image at the furthest distances.
But how do you? But this is a question for you, real question. How do you know? Why do you say that? How do you know it's at the furthest images?
Because it's visually obvious. Because it's visually obvious what's occurring.
What is the visual obvious factor? Like, is it what you think it's distortion, or what are you looking at that makes you say, refraction?
No problem.
It's not in focus, mate. It's not in
you.
focus. That's what tells you refraction's not a play here. It's not in focus. Okay. Answer next question.
That's not true, but that's not true. But if you want to believe that, you can.
No problem. I'll show you. If you want to click on my screen, I'll show you exactly what I'm talking about.
I'd love to see it.
Hey, is that in focus? If that was in focus, you could see everything on that island. So it's not in focus.
So what does that mean?
There's an intensity to light. Hey, listen, do you know about the intensity of light when light goes through a medium?
Yes.
When it reflects.
But it doesn't necessarily.
What are you talking about?
If light goes to a medium, if it's denser, then it'll slow down. If it's less dense, it'll speed up. But it won't necessarily diffuse. Out of focus means it diffuses.
All right. Okay. So when it slows down, when it comes out, say I had a foot-long piece of glass, right, and I had two torches. I shone one torch through a bit of glass, a foot-wide bit of glass, and another torch pointed straight at you, not through the glass. When I switch it on, will you see the time difference?
I was trying to pay attention to Nathan. Can you hold that real quick, and then I'll try to answer it? So this is where you say refraction's happening, Nathan?
We can see the effects of looming, where this very tiny portion of the island appears to be levitating above the water level.
Okay, so can I ask you a question? Oh, I see. So you think that's the bottom of the island right there, and the looming effect is making it appear to be separated. Is that right?
That is literally what is happening. I can demonstrate it visually. It is evidenced. QED.
Okay. Can I ask you, is it possible though that that's what you're saying is not exactly what looming is doing? Because isn't it possible that what looming is doing is bringing things over the curve, which causes distortions on those edges, but it applies all the way across the water?
In Fantasyland of Globeheads, that's what you say it is doing, because it must be.
I'm only asking the question, but let me just say what you said.
I'm telling you the answer. It must be doing that if you live on a globe. It must be, because there is a massive wall of Earth between us and the target object. So in the globe world, for the people who keep saying, why can't we see the beach? It must be looming. The entire thing is a mirage. It must be. There's a wall of Earth in the way.
Okay, so you're absolutely right. The globe model is broken if refraction doesn't exist. Like basically you guys win if we don't have refraction. No doubt about it, right? Like you've proven that the Earth is flat if there's no such thing as refraction. Right? Isn't that true?
I think the Earth is obviously and observably flat. When people like Tony say, what are you going to do now you've shown that it's flat? And I go, well, this isn't a revelation to me. You know, I'm still going to continue doing what I do. It's not a revelation to me. I knew it was flat before this. This is just yet another proof.
Yes, but you seem to think that refraction is somehow like a cop-out. But I'm just saying, if it's a real thing, yes, we do need it, because without it, everything looks wrong, right? So obviously we do need it, but I don't know if it's a cop-out, right? We think it's a real phenomenon. We have reasons to believe it happens. And if it happens on the edge, it's going to happen all the way across, because it's really about different densities of air. So if there's something about the air between us and that corner that's different densities along the way, then it seems like it would be the same near where the lighthouse is, and then also on the left-hand side too, right?
No, because what we have is a bigger problem. If you're saying that the farthest right-hand side of the image, the bit I just showed you, is behind the curve of the Earth and looming and suffering these effects of mirages and what I term as hologrammatic projections of the land, why on the left-hand side, when we are seeing considerably further with a much bigger wall of Earth curve, do we see ground down to about, 15 meters high? It's ludicrous to assume that it's a projected image that has managed to scale itself perfectly, beautifully, and in proportion all the way along the scale of the curvature. It is a fantasy.
I agree. The looming should be pretty standard. Like, there should not disproportionately change just to suit the picture. But I agree with you. That's what you're saying, right? Like, it's not going to magically be this proportion over here and that proportion over there, right?
In other words, there's no evidence of what you're suggesting when you show us the maths. There's no evidence of it whatsoever. What we see is the village, the lighthouse, down to the shoreline, land that's really low. Basically, we see what we would expect if we lived on a flat plain, because we do.
That's not entirely true, but my understanding is the only place we really put attention is on this lighthouse. So if you say there's a place on the far left where you've seen all the way down to the ground, like that's a whole different concept, right? I guess that could be true if you show it to me or prove it.
Yeah, we have. But the problem is that people like Paul don't like to focus on that part of the image because then we're at 50 miles away, and then we've got a mile of wall to contend with. He'd much rather focus on the lighthouse because it's much, much closer, but as he demonstrated yesterday, it's still not visible. There's still earth curve in the way. We don't get to see the bottom of the lighthouse and the beach and everything else unless we start to gish gallop about refraction. Bottom line, doesn't matter what you do with the altitude of the observer. We are still blocked by earth curve. It doesn't conform to your model. It doesn't make any sense. The only way it makes sense is if we have line of sight with the things we see, and we do.
But okay, I agree with you. If there's no refraction, right, obviously it's like a done deal, right? So when he says, you know, we need refraction to see, which you call, let's say, a holographic projection, I mean, that is a fair thing to be saying, though, right? We do think that does happen. And so we need to figure out whether that's the case here or not, right?
Well, no, it's just a presupposition that necessitates it to happen. You have a presupposition that it's a globe. Therefore, we need to start to find answers for why we haven't got a wall in the way. Well, it's simple. We haven't got a wall in the way.
Okay, but so I actually agree with you that I find that the Globers on this debate often refuse to give you guys any inch when it's totally reasonable to. Like, I think you guys say a lot of true things. Like, for example, there are major problems with this photo. Like, this photo should, you know, there's problems. We got to figure this out. But, and I also see you say things that people say, like, well, then, you know, you'll say, do we have a line of sight? No, we don't have a line of sight. Or we have a apparent line of sight, but we don't really think it's real. And so we're trying to tell you it's a hologram, or, you know, a holographic projection is what you call it. But I think that's the question then is, are we right or wrong? Now you're saying we're wrong, but you're saying we're wrong not for a very good reason, though. You're saying we're wrong because we need it, but it might be true too. You know what I mean? It's like, if it's true, then that's why we need it.
Yeah, that's just a presuppositional argument. Presupposition that you are under says we are on a globe. Therefore, you're phrasing this. Your mind is wired to phrase this as there's a problem. There's no problem. It's just a picture of stuff. In fact, if you analyse it if you just showed that image to someone, they go, what a boring image. It's just a picture of the Isle of Man. How boring. There's nothing exceptional about the picture.
Science, though, Nathan, that a lot of times what we see does not match up with our expectations. And so for a long time, we think, oh, it's what we see. It's obvious. And then science comes along and starts asking harder questions. And then one day we realize, oh, no, there's such a thing as germs. And that's what's happening. And so this is this. Yes, you're right. Apparently, with just our eyes, we get one answer. It may be the right answer, Nathan, but I think to say that refraction doesn't actually happen, it was just a made-up thing.
I haven't said that. Do I need to go and show you whether the refraction is actually occurring in the image and evidence it to demonstrate again that I do understand that refraction occurs?
I think refraction occurs evenly across the whole image. I don't think you can eyeball where refraction happens and where it doesn't.
Right. Well, I have literally just shown you that. I have literally just eyeballed it and identified it for the audience. If you want to now show, hold on. If you now want to identify along the entire island where there's refraction, you be my guest.
I claim that you can't identify where there's not refraction.
So we can't. So it's like the Emperor's New Clothes. It's there, but we just can't see it.
Yes, I think we have to figure out.
Amazing. I call total bullshit. Emperor's New Clothes. People who are fantasists deciding to put their presuppositional ideas onto a very clear image of something that is very boring, very standard, and making up fantasies to account for a curve that isn't there. Well, I don't care about your logical fallacy when it comes to living on a globe. We just got an image of an island. It's simple.
What you think is possible, but in order for you to be right, you have to be saying refraction does not happen.
Right, and I'm not saying that, though, am I?
So then why are you saying it's a fantasy?
Because the fantasy is that the entire island is looming above an imaginary mile-high earth curve that we don't see, don't experience, and has absolutely zero effect on the light. If the light... Wait, hold on. If the light is bending, I would expect that to be evidenced in the image. So when I've asked Paul to say, okay, if we are experiencing refraction, show me some evidence. So show me some pictures that say, here is an item in the distance that is being refracted, and here is how it looks. I
don't think refraction is going to be apparent visibly.
What? Yes, it is.
Could I say something? I'm presenting now, Nathan.
I'll shut up from now, Ranty. I'm getting way too involved.
Okay. So here we're seeing the island, and obviously we've got Snaffel and what have you, but that's hidden in the clouds over here. You can't see the top of it. But you say that this here is looming. You know, it's being refracted up so we can see it. Is that correct?
You mean the whole right there? Yeah, I think that's refracted.
Okay. So when we go a little bit further up and we've got this little village here, do you think that's being refracted up too?
It's hard. I don't know. It's hard to say. We'd have to figure out what the apparent height is versus the real height.
Okay, because I can tell you now that you should be able to see that if we live on a ball.
Okay, I believe it. I believe it.
So you should be able to see that if we live on a ball, and you shouldn't be able to see that if we don't live on a. If we don't live on the if we live on the ball, we shouldn't see that, and we shouldn't see that. But you're saying that we're seeing this because of refraction and looming, and yet we're seeing. But this is what
I'm really saying. Right? I'm saying that because I'm saying that if standard refraction is true, and that's a question, like Nathan is sort of arguing it's not, but if it's true, then we should, and we're at 100 feet. If that's also true, then we should see some of the lighthouse. I don't know if we see the right amount. I have a way to figure that out, but we'd have to answer that question.
Well, my question to you is, where between this image here of the lighthouse and this of the village, because you can see this in a direct line of sight on your model, but this you can't. Yeah, so somewhere between here and here, there's some kind of lifting up. Being lifted up.
But you're right. But it also could be that the town is higher than it should be because of the same looming. That could be consistent too, right?
Yeah, but
because we don't know that the town isn't looking a little bit higher than it should.
You see, where that falls down is the fact that all this is exactly how you would expect it to be, height-wise and distance and everything between each other. So if that's being lifted up, and realistically its real height is down here, then there should be a difference between the sizes of each.
So looming could possibly bring everything up equally, right? That's definitely one of the possibilities.
So if it's bringing everything up equally, are we talking that it's bringing the entire mountain up? You know, the 2,000 feet mountain over here?
The possibility, but I personally would suspect that at some point there'd be a compression effect. I don't know if we could spot that would lower it, but I don't know where that would be. It's also possible it could be the whole mountain up.
Because this band of refraction, you know, most of the stuff you see is pretty low down, you know, so maybe if you're looking at a distance of 31 miles, you could say 300 or 400 feet might be affected. You know, when we're looking at Blackpool Tower, you can see distortion from 29 miles away on Blackpool Tower to about halfway.
The thing that makes it tricky is that, like, to be honest, is because the light's hitting the eye or the lens. That means that there's a common part of air that it's going, all the light is going through, right? Every piece of light is going through some common section, and it might be that's where the looming's happening, is in the common section.
Okay, so what we're saying is if this is a looming area here, then this is.
I'd just like to introduce myself, if that's okay. Thank you.
Yeah, hi, Lottie.
I'm
how
Lottie.
You doing?
Thank you.
Yeah, I would have got to you, Lottie. No worries. Good to have you.
The looming area, you know, this is out of the reach of the looming area because it's too high. You're looking at 1,500, 2,000 feet up here, but it's all consistent. So somewhere along the line, the looming has happened, but you would expect it to be squished somewhere in the middle where
that's what I'm saying. Is it's possible horizon not to be squished. It's possible for the looming to be uniform all the way up, right? Because it's possible. It's also possible.
That's what I'm saying.
The problem there. Sorry, Ranty, I've got to add this in. The problem there is that the amount of curvature that obscures is varied as we go from. We're going the other way at the moment, so we're going down into. Here we go. As we go this direction, we're seeing further and further and further over the curve, according to your model. The problem is that means we have to have a varied amount of looming, bringing stuff that's at the left-hand side of the image back considerably more when we get to this end, than at the beginning half of the island where we see a tiny bit of refraction, what you globers tend to call hidden by curvature. So at this point of the island, we're behind a mile of curvature, but we're not seeing any difference in the image.
I'm here for my money. Thank you.
Sorry, Lottie, what did you say?
Ranty, can I get my money, please, Ranty?
I knew this would come up. I can prove it. We're going to do the hangout later, aren't we? So. No,
you said today. Today is now. I want my money.
All right. Do you want me to do the thing right now for you?
Can you explain what's going on, Lottie? Okay. Just tell us just fill the audience in, please, Lottie.
So I'll tell you what's going on. That'll be easier. Last night I entered into a hangout, but I was in the chat, and the argument was that I said that there would be 3 caravan sizes from where Anthony Riley was standing down to the top of the rocks. They tended to disagree in Imbrick's channel, and I said, well, I can prove it, and a bet was struck as to who would be correct. So let's get this image up. Am I still in the hangout? Hello?
Yeah, you're still here, mate.
Oh, right. Okay. I thought I'd been been sniped or something. Right. Okay. So let's go and let's do this now, shall we? Right. So we know that these caravans here are 12 feet.
Stop. You can stop right there. No, we don't. No, we don't know that. What's that?
Yes, we do. Anyway.
No, you don't. We mean implies us. I don't know that, so you're incorrect again.
Well, regardless of whatever you're going to say now, all I'm going to do is draw. This is where Anthony Riley was standing. There. This is the top of the rocks. Down there. So if I can get 3 caravans there, crop 3 caravans out and plot them down 1, 2, 3, I win the bet. It's as easy as that.
Oh my God.
And it really is a pointless exercise, but
it's pointless, but yeah.
It's quite entertaining. Right. Right, let me copy that.
How you doing, Sleeping Warrior? Good to have you here.
And we'll go back here. So I've copied it now. So all I need to do is paste it 3 times. There's 1.
Is this what? What a fucking knucklehead!
What?
Ranty, you know you're a knucklehead. Why are you doing this?
Why?
Yeah, you've been in before, Lottie. You don't swear in this hangout. It's simple. You know, once people have been in and established themselves and had a few introductions, you get 1 chance to not swear. So, welcome back next show. Please don't try to rejoin.
What's happened there? So someone being kicked?
Yeah,
Missed what
he
you're saying.
called
Right,
you an
okay.
effing idiot or something, and it's like, I don't need my kids subject to that. I don't need the audience subject to that. I just don't want swearing on the show. It's only one. There's one rule here. You know, welcome back next time, Lottie, as I say.
Oh, right. So it was Lottie that was kicked, right? Okay. So I've done that pretty quickly. I know I've already done this image before. So it's probably, it's 3 and a bit, but doesn't really matter.
Yeah, it's tricky. I mean,
I'll do it properly another time. So go on. So where were we up to anyway? What were we doing?
Nathan was making a point about the far end of the island.
The far end of the island.
Far left end. He was saying.
Oh, sorry. Yeah, sorry. I'm confused now because he just hijacked the point. What we were saying.
That is a good place to focus.
Here we go.
If that far end is the actual end of the island, if that's not different than what the actual end is, that in of itself is a very strong argument for you. But I claim that won't be the actual far left end of the island.
So what would you suggest this is then? This part here.
Well, no, that's part of the island, right? So he's going the very tip. Let's go the very, very left tip. I think that's what he was saying. So see where it finally goes in the water.
Yeah.
So if from where we're standing, if we're just looking at the true island as if it's flat world, that should be like the leftmost point we could possibly see of the island, the leftmost point of the island, period, right?
If you're looking at the Isle of Man, if that's the Isle of Man.
Yeah. So on a flat world looking at Isle of Man from St. Bees, that point would be, we can figure out what the distance that point is, right?
Yeah, well, I've got it on the maps ready to go.
So if that is actually that point and we're seeing it, and it's like, I think it's a ridiculous amount of curvature that it's being brought back from. I don't think anyone would be claiming that.
So if I put the ruler on here and we do a measurement from the very tip, right?
Yeah.
So where he was standing, I think it's about 50 miles.
Right. And so when we do the curvature, that's going to be very significantly behind curvature. The chances of that being brought up
is 51
looming is very low.
51 miles, 51.1.
Okay, so that begs the question. When we look at the picture, is that just for sure that point? Because it's going to look like that point if you raise the water up. The point just shifts to the right. But from our eyes, like, how do we know for sure we're looking at the right point? We'd have to measure the left, the horizontal distance or something. Or we need a landmark. Like if we just magically,
what do you mean you'd need a landmark?
Like if we just magically raise the water, say 3 feet, then that silhouette that we're looking at would look different, but at the two edges, it would look the same. Like it's still going to dip down into the water exactly how we see it. So we got to figure out, is that truly the same point that you're drawing a line to?
What, here? Oh, yeah, definitely.
How do you prove it? I'm claiming that's not been shown. That's an assumption.
Okay, well, somebody did a trigonometry. Was it? Who did the trigonometry now? Somebody did came in and did a trig experiment, and basically lined up the island and everything. All, you know, he had like the lighthouse and, you know, all kinds of different landmarks, and he was able to categorically say that it passed.
I'm going to go out on a limb. I haven't seen every second of this debate, but I'm going to go out on a limb and say, I don't think categorically. I mean, just yesterday, it was still going to get debate over whether this was the right lighthouse, whether we're seeing Ireland or not.
You see these two here, these two little villages here. They are these here.
Okay, so let's say that's true. Then what?
That's what they are.
Okay, so if that's true, then what does that mean?
This little part here, well, I'm just lining it up for you.
I know, but how are we going to show that far left is the point, though.
So, what? Sorry.
How are we going to show the very far left is the exact point that you're drawing a line to?
It was done by trigonometry.
I don't think it was, is what I'm saying. I don't think
it was on a hangout about 4 days ago, something like that. 3 days ago, 4 days ago.
So you're saying,
Nathan, who was it who did the
it's in one of the shorter videos. I can't remember the exact title. I'll look it up now. Bear with me a second. It was called.
So is the idea that you're saying even the globe side of you guys is saying that that's the far left island and that there's no island being hit by curvature at all?
Well, it's a possibility that what we can see is down to a point. Say, let's say we can't see this area here, but what we are seeing is in the background we have island. And we have the mountains in the background here, these mountain ranges here. It's a possibility that what we're actually seeing at the far left is these. We're not actually seeing down to.
Okay, so whoever did the trig, then we don't have an answer. If you think those are both possible, we should have been able to answer that. Is my point. Because you could imagine that you bring that red line to the right, and it would still look like it looks. Bring it to the right, say 20 degrees.
Let me show you something. Let me show you something here, right? If I draw, you see this straight line? This is a straight line here, right?
Yeah.
Okay. So I'm going to put another straight line in here and watch what happens when.
So you see that yellow line?
Wait, watch what happens. Can you see what's happening to the yellow line?
What's happening there?
Can you not see what's happening? When if I put it, it's curving to the left. It's following if you look at the horizon in the background, they've already got it curved, right? The horizon on the background is already curved. This line is now starting to curve to the left. What you're forgetting is that this map is modeled on a ball.
Oh, you're saying they automatically curve these lines to count? Is that what you're saying?
Well, what I'm saying is that you see these mountains here. These mountains, if they were on a flat Earth, there's a possibility they could really be here.
Okay. Do you understand what I'm saying, though?
But because they've stuck it on a ball, right? Because they've stuck it on a ball, the line of sight has taken it to the left.
Right, that's one possibility. So do you know the other possibility? What if you do the other way, to the right?
Well, yeah. But this is what we're saying.
If you take that red line, and you shift it to the right, and you say that that's where the water line is, then it will look exactly like it does.
Yeah, but we've been working on this right-hand side with these mountains in the background. And what
but Nathan made a point that left-hand side was the point that is the far left island. I'm saying if that's true, then you've proven flat Earth, and I'm saying it's not true.
Yeah, we are saying there's two choices. Sorry, let me just clarify it from Renty. Sorry, Renty.
Or whether or not it's island is entirely up for you to decide.
Exactly.
Yeah, so I'm saying though that left-hand point cannot be the far point. Or if it is, then you guys definitely have proven it, and I'll switch. But I'm saying you haven't proved it's the actual left-hand point of the island. That's the problem. It probably isn't.
Here's the issue. We've got from why is it not working? Right. So let's say this land is the land that's in
underwater or
in debate. This is the debatable area, right?
Okay.
We can line up all the other stuff, and then this stuff here is debatable. So it's either the Isle of Man here, or it's Ireland in the background.
So you're assuming that what you see is equivalent to what's there. I'm saying, look, Imagine what it would look like if you don't see Ireland and you don't see the area that's in the bait. Okay, imagine what you would see as a silhouette. You would see the same kind of silhouette.
You think this is a silhouette?
Yeah, yes. Imagine that as a silhouette. You see it now. If you do the math to figure out how much distance are you seeing horizontally, you can find out how far are we really seeing. If you like, you can imagine the sweep of the arc. We can actually find that out. But until you do and you show that it's actually sweeping all the way to the end, then we don't know how much of the land we're really seeing.
Well, this isn't a silhouette. These three buildings here, the buildings that are, I've identified.
I don't mean that you're going to look at it and see a silhouette. I mean, you pretend overlay a silhouette so we can talk about that aspect of it.
1, 2, 3. These three buildings here.
Okay, so then you can use those to help figure this out, right?
There's the villages next to it.
Yep. So you can use that to help figure this out.
Yeah.
We've done all that. Sorry, I've got the name of the video now. So it's called Flat Earth Proof: Ireland and the Isle of Man Seen from England.
And what we're saying is that Douglas, which is here, this is Douglas,
mm-hmm.
and we go over this way because they originally said that you can't see Douglas, that that it doesn't line up. Okay, so
have you proven that it does?
Sorry?
Have you proven that it does?
Well, what we're proving is that we can see these. We've seen these three buildings here, and there's Douglas just to the left. So when we go on here, we've got the little village there. We've got the three buildings here. So we know that in a direct line of sight, this is Douglas.
Oh, no, that's not what you know, though.
Well,
that's not true. No, because it could be the thing in front of Douglas.
What do you mean?
Go back to the map.
Look how far I have to look. If I
that's my point. This is the point right here. That thing you're doing right now, where you say, "Look how far." That's what I'm saying. Is you can't do that. You got to figure out exactly how far. How much am I seeing? Because you're eyeballing it, making these guesses, and that just invariably is going to get you the wrong answer.
Okay,
now,
but
you might be right.
Let me just explain it one more time. Let me just explain it one more time. Sorry, Ranty. Let me just give it in one more time. There's only two things that land can be: Ireland or the Isle of Man. That's it.
Correct.
There's no third choice.
But Nathan, what point on the Isle of Man does that correspond to? Do you think that's obvious and guaranteed?
No, I've just said there's two options. It's either the Isle of Man or Ireland. In either instance, neither, Ireland being considerably worse, neither conform to the globe model at all in any way, shape, or form. Neither do.
That's not true, and can I explain why I think that's not true?
Go ahead.
Because when you say it's the Isle of Man, you haven't told me where on the Isle of Man it is. There are points that we could pick and say, this is the equivalent of what we're seeing in the photo, and that equivalent point would actually be consistent with the globe model because it's higher and to the right of what we're actually hiding a lot of the Isle of Man without realizing.
Well, I've just told you.
We have done that. So I'll tell you the name of the video again. So it's about 1, 2, 3, 4, 5, 6, 7, about 8 videos back. It's called Flat Earth Proof: Ireland and Isle of Man Seen from England. And what has been done is this photograph has been put into a program called Blender, and then it has been modelled so you can see exact line of sight with where we are looking at. And he has triangulated this using the main feature that is definitely obvious, which is the lighthouse. It's definitely what we're looking at. And he's got it to within half a degree. You know, he's got it to phenomenal accuracy. So for you to say, no, you don't know what that piece of land is, we don't know what that piece of land is, as I keep saying. It is either Ireland, as Ranty's saying, it could be the mountains in the background by the virtue of the way that Google Earth works. It does curve the line of sight. Now, whether or not it's curving it unnecessarily is based on if you believe you're on a globe or not. But the bottom line is, that piece of land, there's only two things it can be. Ireland, which leaves you, I don't know, 5 miles behind the curvature, or the Isle of Man, which is at a distance of 50 miles and leaves you 1,000 feet behind curvature. So you're screwed either way. Neither conform to the model. If you want to tell me it's Ireland and we haven't identified it correctly, that's fine. If you want to say that it's that land that's 15 meters high at 50 miles, that's fine too. I don't care what you identify as. There's only two choices.
I think I must not be expressing myself well, because if you told me there's a model that proves to you that leftmost point is equivalent to a certain point on the Isle of Man, then you would not be in doubt of whether it's Ireland or Isle of Man. You would know.
There's two things in front of each other, so it could be either, because they are both one in front of the other.
So that means you don't actually know which point on the Isle of Man that has to correspond.
No, right? We don't. But it doesn't matter, because it doesn't matter if you pick Ireland or the Isle of Man. Neither fit the globe model at all.
Nathan, if I can pick any point I want on the Isle of Man, then I'm safe, right? Because I can pick a high point to the right.
No, you pick the bit that's lined up. You don't just
That's
pick
what
an
I'm saying.
arbitrary
You haven't
point.
proven it's
I've just
lined
told you
up.
this 3 times. I'll tell you again, if you want to go back and watch the video, it's up to
I'll
you.
go watch the video, but you're not. If you don't know whether it's island or Isle of Man, you have not lined it up then. Because if you line it up, you will get the answer definitively.
Well, you have lined it up, and it's
you just- why
either
do you
Isle
know
of Man
about
or
it?
Island,
Then why do you
but
not
the
know if
two
it's island or
are
Isle
in
of Man?
front of each other. So you
So
can't...
which one's in front of which?
You tell me.
So then why are you saying it might be Ireland?
Because it's directly behind it.
But you're looking at the bottommost point, right? So Ireland would be behind that bottommost point, and you're saying that that bottommost point is in the line of sight, and you can see
Ranty's
it, right?
showing
So
you
it's
right
not in the Isle
now.
of Man.
Ranty's now doing the line of sight. So you see the left-hand red line that he's now drawing? Well, there's only 2 things that we can be looking at. At the very left-hand side of the image, right, we've figured out what the most left tip of the Isle of Man is, and that's that tiny little peninsula that sticks out. That
Is that
where
the
it crosses.
same point with the leftmost tip on the picture?
Yeah, so it's either that or Ireland. Take your
Okay,
pick.
it's not. That's not true though. I mean, that you can
What's the
say
third
that
option?
over and over, but that doesn't.
What's the
It
third
could be
option,
another
then?
point on the Isle of Man.
What's the third option?
It could be another point on the Isle of Man.
Which
to the
one?
right of that
Show me.
leftmost
Which
tip.
point do you think it could be?
It could be any point depending on how much curvature is blocking Ireland.
Right,
Like, if
so
you draw-
hold on,
let's
so
make sure-
hold on. So what we're saying is forget the image that we can see land all the way to the left. We now go with the presupposition of curvature and refraction and all these things to figure it out. Is that correct?
Yeah, yes.
Right.
So I can explain this. It seems almost like you're whiffling, not trying to understand. What I'm saying is, if you look at the picture that you have of Isle of Man, right, and just look, I'm not trying to prove anything. Let's just prove the concept. You just draw a straight line across the bottom, and it's above where we think the horizon. I think I even saw, I think maybe Ranty made a line like that once. You just draw a straight line across the bottom, and then you look at where is the leftmost part of the island that you see above the red line. You'll notice that it looks indistinguishable from like that little piece of geography right there. It's going to go right into the water, just like it's the end of the island, right? Does that make sense?
So like some of the islands refracting over the horizon then.
I'm just saying, if you look at the picture, you cut the picture in half.
Is that what you're saying?
Modeling.
Just some of the islands refracting. The other stuff's not bothered coming up with the rest of the island, yeah?
Yeah, like my argument is another way to just actually solve this whole thing is just to say.
So that's what you're saying. You're actually saying.
I'm saying if the water is up, then we have to make sure that we're seeing what part of that left-hand part we're seeing. Because if we assume that we're seeing the far left and we're not, then we get a bunch of errors.
Yeah, but they've done the calculations of the height along that coast, all over the coastline, and it should be below the horizon.
Again, that's if it's the one you think it is.
No, but it doesn't matter. It doesn't matter. If you pick any one of these 3 lines, and every single one of them will come up, most of it should be hidden behind the horizon. And that's that. So that bit, the first red line on the right-hand side, that part of the island's decided to refract, and the other hasn't.
No, the whole thing's going to refract the same, I think.
Right. Okay.
So
Then. So that last line. So we have to agree then. That last line there that ran you, the last line of sight, the last part of that island is that last line there.
No, that's not what you guys have shown. If you draw the line,
Well,
like
that's his line of sight.
Okay.
It has to be.
no, you
It
guys can
has
say
to
that. That's not true.
So you see
It
this
has
last,
to be.
this
Listen,
last
that's a
part
guy.
here.
He tells you it has to be.
No,
this last part that sticks out.
Yeah.
You know, this is the line of sight still includes this or island. So if we go to this piece of land here and we hover over here for an elevation of the actual land height,
yeah.
Can you see that we're looking at 16 meters, 15 meters,
Yeah. Okay,
12
good.
meters?
So we should not be able to see that, right? On a globe model.
Well, it should be like 330 feet behind,
Right.
330 meters behind.
Right.
The
You
curve,
have to be
and it's only
crazy to think that Lumi's
15.
going to bring that up, right?
Sorry?
And you have to be crazy to think that Lumi is going to bring that much up, right?
Well, I would have thought so, yeah.
I would think so too. So I'm saying that's why we kind of know that's not the left-hand part that you're looking at. You're looking at something that's not in the picture. That
So
is
would you be saying it's something that's probably
That's
twice
how
as...
it's done.
Nope. I'm saying it's to the right. I'm saying it's Isle of Man to the right.
So could it be twice as far away?
No,
but
I'm not. It
150
couldn't be that either. That's not what I'm saying. You're
160 meters? Could it be that?
wrong direction.
Could it be this? 160?
No, I'm saying no. It cannot be that. Wrong direction. You got to go the other way. You got to come back to where you were, then go to the right, and then you'll see what it could be.
Yeah, but
But
we've
it
just
doesn't know
explained
that.
this to
It
you
goes
too.
further than
Even if
that.
he goes to the right, all of the stuff on the right should be behind the curve too. It makes no difference if you go right and say, oh no, we can't see that far left, we're actually seeing this bit that Randy's got his hand over now.
Yeah.
Even then, that's still
53
behind the
meters.
curve. It's still got the
But
same
then- but
problem.
Agree. But there's a point where it stops being behind the curve, right?
Yeah,
Because
that point's beyond the lighthouse, right? That first lighthouse.
What do you mean?
That's where the curve stops, beyond the first lighthouse that we was talking about right at the beginning.
Elevation is much higher for some of those parts. So we have to figure out, there's going to be a point, right? If we start sweeping to the right, there's going to be a point where the first thing we should see occurs, according to the globe.
Go right up to the lighthouse that you started with the conversation with, and then you could start arguing over the refraction on that again.
Yeah, I mean that's why people focus on the lighthouse. But I'm just making the point that going to the left and calling that the same point as on the map is not fair. Like you can't do that. You have to figure out what is that point.
Well, it is fair because that is what the land is that we're seeing.
But how do you know that?
Well, it's been mapped out precisely. It's been triangulated with 4 reference points.
It's been mapped out
exactly
precisely.
what we're looking at.
I don't understand how there's so much confusion because then you wouldn't say, is it Ireland? Is it this? Is it that? If it's been mapped out precisely, you'd know the answer.
Well, the confusion comes from there's that little bit of land in front of it that's 15 feet tall. And the argument is that how do you know you're not seeing that? And that's a fair point because we can't see the divide between the land in the foreground and what we say is Ireland in the background. However, even if it is the land in the foreground, it's still Isle of Man right at the far end. It's 50 miles away. It should be 3,000.
Not if what you're actually seeing is a different part of Isle of Man. You guys keep assuming that you're seeing everything and then using that assumption to show that you're seeing everything.
So what's this land then? What is this land?
I'm saying that would be to the if we imagine
There's Douglas. There's Douglas.
No, if we imagine the hand of a clock, right, and it's pointed right at the very leftmost tip of Ireland. Oh, no, I'm sorry, of Isle of Man, and then it sweeps to the right. Okay, starts sweeping to the right. Now it's covering the Isle of Man. At some point, we're going to hit an elevation and a distance from us that we can see according to the globe.
This is to the left.
I'm saying that's what the point will be.
This is
Scott, listen. At 100 feet of observer height, you see the tip of the lighthouse right on the far corner. The tip of it. So that's where your curvature starts at 100 feet.
You see 33 feet there, and you have to figure out what the distance is too. But for example, is there elevation to the left of the lighthouse that's higher than 213? Yes. So we might see that first. So it's like you just leave one of the 2 variables out a lot. It's like it's distance plus elevation. Then we need to know our height, and then we just can sweep along, and we can just get an answer. There's going to be a point, which is what the globe says. Here's the first point we can see.
Well, I think we need to remind ourselves that the first point.
Listen, guys, you should stop jumping through hoops for these idiots.
No, he's trying to learn though, isn't he? He's at least
no,
open.
he's not. He's not.
No, he's not. He's
trying to get into the Ball Earth Club. That's what he's doing. He's getting initiated. This is an initiation, isn't it?
Look, I'm telling you guys are right.
He's trying to become popular with the Ball Earthers, like Lewis did as well.
God, give me a break. Look, I think those guys are wrong a lot of the times. And I think they have a terrible attitude. I think their tone is awful. I'm not trying to get popular with them. I'm telling you what is true that I think. If you think I'm wrong, you can tell me why. I don't know why you guys are so aggressive. This is not a kind of a debate that needs to be like so vitriolic. Just talk about it.
Because what we're dealing with is an apologist. That's what we're dealing with.
With an apologist?
Yeah, an apologist. You're making excuses for a model that's broken, and it's frustrating. You know, we just see this stuff, and you're saying, well, let's look to the right. Well, the problem is the land isn't to the right, it's to the left.
I guess I'm saying that I think
within
you guys
half a degree.
Completely carefully considered the
on a video that you've not watched. So you're arguing from incredulity, and it's pathetic. It's annoying, and that's why we're getting frustrated with you.
Well, to be fair, have you guys ever not gotten frustrated with anybody?
Yeah, and to be fair, he is a lot nicer and politer than the other people that we speak with. Credit should be given for that. But if you watch the Hangout, the short interval with Chris Monk for about 20 minutes, 25 minutes worth, you'll see how it's been mapped out and modelled out, and it's pretty accurate. Whether it's Isle of Man or Ireland, it should not be seen. It's that simple. So, yeah, it is an argument from incredulity at the moment.
Well, there's one thing that's definitely true, right? Is that we are seeing things that without refraction, we should not be able to see. And even with refraction, we have to be assuming a dubious height of 100 feet. So that's definitely a problem. But you got to, my sort of feeling is you got to take these problems and you got to smash them down one by one. And then when you can't get one smashed down, that's where the answer is. But what happens is none of these things actually get smashed down. They sort of get talked about, almost smashed down, and people move on.
No, they get dismissed and people move on.
Right.
They don't get addressed. They get dismissed.
Right, which I think is a problem on the globe side, because like this is a problematic photo. This photo, you can't really dismiss these pieces. Like if Riley's correct, then we see a lot of stuff, and like something's going on here. It's probably refraction, maybe a little bit of confusion over height, but maybe not. Maybe it's proof.
Well, I'll be going back there in the beginning part of January. I only need an half decent day, and I'll come back with more footage, and it'll be very, very similar. Maybe it's the case that it won't be quite as good. Maybe it's the case that it'll be a little bit better. Maybe it'll be a little bit more clearer on our side. Maybe it won't be. But in any event, if I repeat the observation and I get very similar results and they're open to interpretation, but of the same kilter, it's going to be difficult for anybody to argue that they were non-standard refraction, because it would be very unlikely to get non-standard refraction that happened to be exactly the same.
I agree with you. I think that if you go back and you do that, especially with all this in mind, the chances of you not being able to come back with something fairly conclusive is very low. I think anyone that's going to dismiss the next step, I mean, they'd have to really show that you did something crazy.
And the other thing is, I didn't do this. This video that people are looking at, I didn't do this with the intention of looking at Isle of Man at the time, or Ireland. I was actually up there looking for Blackpool Tower. That was my original reason for going, but it's too small. It's just too far, too small. And you guys would say it's behind the curve. We would say it's too small. If the inverse square law applies, it's just too thin, too small, can't pick it out. Either way, I couldn't see what I went up there for. But what I could see was what I documented. And rather than come away with nothing, I came away with that. Ranty only noticed it last week. He started just double checking over it for some weird reason, and I had no idea he was doing it. And then he said to me, "Just have a look at this and see what you think." And I looked at it and I just thought, "Oh my god!" And then for me, it was a moment of just sitting back and just thinking, "Is it what we're looking at?" So then,
is it possible? Is that thing that I think Ranty made it? Is that thing that Ranty made? Is that available where I can download it so I can figure out what I'm saying is true?
Yeah, of course it is. Yeah. How do I do that? You have to drop it in. Do you know? You have to drop it in that Hangout link in the back chat. That's how they do it. Are you familiar with how the Hangouts work?
Yeah, I mean, I see the back chat, but there's no link there.
Right, I can drop one in there. Ranty's got the most up to date one. Do you want to drop him a thing in the back chat, Ranty? If you go to hangouts.google.com.
Yeah.
And then just drop it in there. That's how they do it. And the other thing is, if you actually read through the definitions of how light, somebody mentioned it yesterday, and I had to correct them because it was completely and utterly misleading, and I'm sure it was intentional. And I don't recall who it was, but he said it follows Fermat's principle, and it doesn't. If you follow what Fermat's principle for the trajectory of light,
Snell's law that follows, right? Snell's law, right? Is that not right? Oh, maybe I got dropped.
Has he been sniped out?
No, I'm still here. Maybe Riley did.
You still here, Ranty?
Yeah, I'm still here, yeah.
Why are people sniping him out? I'll just bring him back on Skype. Give me a second.
Riley, can I get a link to that picture?
He's been sniped. I'll just bring him back on Skype. If Ranty could do it and stick it in the back chat for you while I'm doing this stupid brill.
Okay.
Did you get sniped? I'll just bring you back in. I've got you on my open mic so the audience can hear you on my iPad, but I'll bring you back in on the PC. I'll just reload it. Just don't call me. I'll call you if you know what I mean. Reach you in a sec. Can you see that link there?
Oh yeah, thank you. All right, awesome, thank you.
All
right, so I'm gonna go away and see if I can show what I'm trying to show, and then maybe if it's still on, I'll come back today or tomorrow or something.
So who's been sniped out? Anthony?
Yeah, unfortunately.
All right. Doesn't take long, does it?
Yeah, a few seconds and he'll be back in the call.
I just want to see
I've just annoyed a load of Americans. I've just called the group that we were chatting last night. Whoops! Sorry, everyone else in that group. I'll just open his mic so we can hear him.
It's all right. Chris will be in bed.
Sorry.
He'll be fine. Don't worry about it. It's interesting. I got sniped when we were talking about Fermat's principle, right?
Yeah.
I'm back in the chat now. Yeah.
Yep.
It's interesting. I was sniped whilst we were talking about Fermat's principle on the trajectory of light. Everybody needs to go and look at Fermat's principle on the trajectory of light and apply it to this thing called refraction, cited by the ballers for bending light, particularly bending light down. Because it doesn't do what, if you actually look at what Fermat's principle on the trajectory of light actually is, it isn't the same as what the ballers are arguing. And it shows that the ballers are probably not being dishonest, but they're definitely arguing from incredulity because they don't realize that it doesn't do what they say they do. And they don't realize that it also doesn't bend down. It bends up, down, left, and right, all directions. Fermat's principle is where we need to be looking, guys.
If we've still got Ranty.
Yeah, I'm still here, yeah.
Ah, okay, the sniping has actually stopped. Excellent.
Ranty, did you hear what I just said about Fermat's principle?
I did, yeah, but I've not looked into it yet.
No, but that's where people need to be reading, because it puts this refraction argument into context, and it does a lot of maths and a lot of science. But if you just read the conclusions, the principles and the conclusions, you don't have to understand the maths. You just have to understand what it's doing. And then you can realize, or then you can appreciate that the light, this refraction, this bending of light is minuscule. It is the way they describe it, is negligible, but it's in all directions. So if this is where when Paul says this is non-standard refraction, I can equally argue that it's refraction, but it's bending up, not bending down, because nobody can prove which way it's going. Because nobody can. I don't know how they would prove which way light's bending anyway. But in any event, the light can be bending up as well as down, and of course we saw that with sound. These 8 lamps on 8 posts, we saw that some of the times the light was bending up, some of the times it was bending down. Who's to say that this light? And if you think about it, if the light is bending up at the end, yeah, we may well see it. But when it's bending down, then it's going to look massively curved, isn't it? So it should be the case that if this is the refraction of the kind Paul argues, that the next time I go, 50-50 chance it'll be bending right the way down and it'll look curved. Like, I'll tell you what I need to do. I'll take Soundly's camera with me and see if I can get it to look curved with Soundly's camera, because his camera makes it look dead curved.
But so I think you're right about almost all that. It isn't saying though that it curves randomly exactly. The Fermat's principle says light takes the path that is the least amount of time between 2 points.
Yeah. But it describes it as going in all directions. It doesn't.
It's a bunch of math, because then you just have to ask, well, where's the dense part? Where's the less dense part? And then you can figure out, like, okay, it's hitting a dense part where it's going to slow down. So then it must be, has to change its angle to minimize the time it's in that slowdown part.
Yeah, but that also contradicts the application of Snell's law, because Snell's law, which doesn't even apply, but they apply it anyway. But when Snell's law applies, it says that when it hits a different medium, it'll bend into the medium if it's more dense, or it'll bend away from it if it's less dense, because that's what Snell's law does.
Joined by Josh. How you doing, Josh? Good to have you here.
Hey Nathan, how are you?
Very well. Good to have you here.
So it should bend right. It should bend towards the normal, I think, because if it's hitting more dense, it's going to slow down. So
yeah, but
the
point I was about to make is if the light hits the angle and then goes either towards it or away from it, applying Snell's law, that indicates that it hasn't got the choice. It hasn't got the choice to decide about the path of least resistance, which is not what Fermat's principle says. Fermat's principle says it'll take the angle, which is like, the quickest route through, indicating that it has the choice when it can. It'll bend around. It'll avoid the more dense stuff, and it'll be attracted to the less dense stuff, and that obviously is not what Snell's law says. Snell's law says it'll go through it and it'll bend whichever ways according to the density of the land, the air it's hitting. So them two things both contradict each other, but one of them doesn't talk about Snell's law. One of them talks.
Technically, Snell's law says it depends on the angle that it hits it, and then if you do some math, Snell's law is correct, but what you're saying is correct. It's just that Snell's doesn't contradict what you're saying. It's going to do the least. Fermat's the easy way to do it. It's going to do the least amount of time. So all you have to really do is ask yourself, if it hits something that's denser and slows down, like how do you minimize the time it's going to take? And so you want to spend less time in the dense thing, more time in the less dense thing, but you got to balance that with the fact that you got to get to the spot.
Yeah, but what the point I was making was that if Fermat's principle about taking the least amount of time involves taking the path of least resistance rather than going through the more denser stuff, that implies that it will bend to avoid the more denser stuff, taking the path of least resistance. But Snell's law doesn't give the choice. Snell's law says if it goes into the medium, it will slow down, indicating that Fermat's principle isn't right, because Fermat's principle indicates that it's taking the path of least resistance, which it can't do unless it's got a consciousness, right?
The least time, the shortest time path.
Yeah, that's right. But the path of least resistance is the shortest amount of time. That, I mean, I did interchange the phrase incorrectly. I agree, but that I was making the point that, in contrast to Snell's law, if it hits the denser air, it'll bend into it. And I'm like,
Snell says it'll bend into the normal. So Snell's is saying, depending on what angle it hits the density, will tell you whether it's going to bend this way or that way. So it depends very much on the angle that it hits at. So I see why you're saying it's kind of contradictory, but Snell's actually has a detail in it that accounts for what you're saying.
Yeah, but Snell's law also requires a hard medium change. It doesn't require what's the special phrase? An isotropic medium change. It requires a hard medium change.
Quick introduction. Sorry to interrupt, guys. Sorry,
then, right?
Scott. Can I just introduce Paul? How you doing, Paul? Good to have you.
Yeah, I'm good. And what Riley's saying is an absolute load of garbage.
Right. Okay.
Saying that
any
the
evidence of molten iron, Paul, showing that it can create its own charge?
Absolute nonsense.
Have you got any evidence, Paul, for molten iron showing that it can create its own charge?
Anthony,
How many times are you going to keep coming back into a hangout, Paul, and having me to ask you over and over again?
What is Fermat's principle, Anthony?
It's to do with the trajectory of light. It's the mathematical calculation for the trajectory of light in a path where it takes the least resistance, or the shortest amount of time. It's a very simple formula.
The shortest amount of time, not the least resistance, the shortest amount of time.
Sure, but in essence, the maths on it is very, very simple.
Snell's law is a simplified version of Fermat's principle. Snell's law drops out of Fermat's principle, Anthony.
Snell's law isn't. Snell's law requires a hard medium change. It doesn't require an isotropic medium change.
Anthony. Snell's law
you're misrepresenting the maths, Paul. That's not what Snell's law is doing.
Yes, it is.
No,
Snell's law is an extremely simplified case of Fermat's principle. That's all it is.
Bring up Snell's law, Paul, and tell us how it applies.
With a well-defined boundary between two media. Yeah. That's all.
And we don't have a well-defined boundary, do we, Paul? We have an isotropic medium change. And it's minuscule.
And when you have a non-homogeneous media, Snell's law doesn't apply, but the laws of refraction still apply.
There you go. So why is refraction? Why is Snell's law given credibility in refraction?
It's a simplified, trivial case of Fermat's principle.
Yeah, but the problem is, Paul, you're using Snell's law to demonstrate Fermat's principle, but Fermat's principle doesn't say light bends down. It says it bends it in all directions.
Yeah, that's right.
Which is a problem because you argue that this is non-standard refraction.
Anthony. It seems to be
this is non-standard refraction, and I argue that there's no evidence for it being non-refraction.
Actually allows light to bend in all directions, depending upon the pressure, the temperature, and the lapse rate of the temperature gradient.
So therefore, how can you argue this is non-standard and suiting your premise, when I can argue equally that it's non-standard but suiting my premise, because light bends in all directions, Paul, not just down?
Yeah, it does. But it depends upon the temperature, pressure, and local temperature gradient, Anthony. You can't just make the shit up.
But that's exactly what you did yesterday, wasn't it, Paul?
No. Nothing was made up yesterday, Anthony.
You started putting in figures that suited whatever you called standard when you were calculating.
I actually showed you a paper where people have actually measured the refraction coefficient. Measured, Anthony. Not
and this is the bit you didn't understand, Paul.
The refraction
you thought that paper was directly relevant. Let me tell you this, Paul. That paper was not relevant whatsoever because you were comparing the observation over ice compared to water. But what you should be doing is comparing water over land. And you didn't do that, Paul. So your whole paper that you cited yesterday was irrelevant. Bit like negligible.
Real measurements of the refraction coefficient to say that it sometimes is not negligible.
But you were doing it over ice compared to water, Paul.
Real measurements from people showing
you were comparing
that the refraction coefficient
Paul.
over bodies of water can vary between +1 and +18.
Yeah, and that was based
Standard
on comparing
refraction
ice
is a value
to water.
of 0.17. I think
Paul,
plus 18.
we're not comparing ice to water. We're comparing water to water or water to land.
Qualifies as
Your whole paper
non-standard,
yesterday
Anthony.
was irrelevant, Paul.
No, it's not, because we're observing over water.
Yeah, we are, but we're not comparing it to ice.
Quite a long distance over water, aren't we?
We're not comparing it to ice, though,
are we, Paul? Do I need to go to that paper again and show you that over bodies of water,
ice, though,
we often experience non-standard refraction?
Yeah, but we're not comparing it to ice, are we, Paul?
Measured, Anthony, not guessed,
measured,
not
agreed.
Calculated,
measured,
reality,
agreed, but
Anthony,
compared to ice.
Measured.
Why would you compare it to ice? Why would you think that was a relevant comparison, Paul?
Why are we still arguing about this?
Paul, why did you bring up a paper that compared it to ice when we're not talking about ice?
What a load of nonsense. You just can't read, Anthony. The sentence that I referred to had nothing to do with ice, and you know it.
Bring it back up,
Shall I bring
Paul?
it up again and show the
bring
viewers
it back up, Paul.
how
Let's read what it says for the third time.
How you have no comprehension skills
Bring
whatsoever.
it back up, Paul. Let's read it for a third time.
Had
bring it
to do with
up,
ice.
Paul. Bring it back up, Paul.
Let me highlight the sentence again.
Yes, and read the whole lot, not just the final sentence.
You have a problem with your comprehension, Anthony.
No, it's not my comprehension, dude. Let's read the whole paragraph in context.
Yes, it is, because the sentence clearly says it has nothing to do with ice.
But in
Shall
the context,
you read the
whole paragraph?
I'll read it for you, seeing as you don't seem to be able to comprehend, Anthony.
Read the whole
Kabashi,
paragraph.
2003, obtained refraction coefficients from +1 to +18 from reciprocal vertical angles for a line of sight about 5 meters over water. Where does it mention ice in that sentence, Anthony?
Read the whole paragraph.
The other paragraph.
Sorry, can I just? It's in a paragraph. It's in a paragraph. It's in paragraph 233. Sorry, can I just check we're on the same paragraph? Paragraph 2.3.3.
Yes.
And the heading of that paragraph is refraction over ice and water.
Yes, Nathan. But you actually have to read the sentences, not just look at the heading.
So please read the sentences, Paul.
That last sentence refers to water, not ice.
Read the paragraph, Paul.
If it referred to ice, it would have said about 5 meters over water and ice. It doesn't. It says 5 meters over water.
Read the paragraph, Paul.
The paragraph says, yes, I know the paragraph refers to ice as well. It gives refraction coefficients.
So why are you citing it?
It gives refraction coefficients of 0 and +2 from vertical angle measurements of the ground clearance between 0.5 meter and 4 meters over an ice field in Greenland. But then the very next sentence says, use reciprocal leveling to measure refraction coefficients in Alaska. He reported a variation over ice between -14 and +10 for lines of sight 1.6 meters above the surface. And then he says, Kabashi, 2003, obtained refraction coefficients from +1 to +18 from reciprocal vertical angles for a line of sight about 5 meters over water.
Yeah.
That last sentence does
Paul, it's
not
comparing
refer
and contrasting
to
it to ice.
Do you have a comprehension
So my question
problem,
becomes,
Anthony? Do you have a comprehension problem? Where does that last sentence say anything about ice?
Right, let me answer to you, Paul.
Nowhere.
Paul, it says he reported a variation over ice between -14 to +10. That's a difference of -14 to 24, isn't it? That's a variation of 24. And then he says obtained refraction coefficients from +1 to +17. So that's down to that's a difference of 17. So why would you bring this up and claim that it's relevant?
Because here he says that over water, Anthony, he is measuring refraction coefficients from +1 to +18.
Yeah, but the point
refraction is 0.17. I think that anything above 0.17 qualifies as non-standard refraction, Anthony.
The point of the paragraph compares a value of 17 over a value of 24.
Understanding
that's what it's talking about.
+5 is non-standard, +18 is non-standard, even +1 is non-standard, Anthony.
And this is where we got to last night, Paul. I asked you to prove that what you were saying about these values was true. Have you got
You
any
can go
evidence
and
to tell
look
us
up these
what the
measurements,
value
Anthony.
of
These
plus
are
1
measurements,
to plus
real measurements
18
taken by
equaling
real people
non-standard
in real
refraction is?
studies.
Paul, you're claiming that these values are non-standard refraction. We're saying we don't know what these numbers
I
mean.
think that anything that is not 0.17 qualifies as non-standard, Anthony. If
To what degree,
0.17
Paul?
is standard refraction, then by that very definition, anything other than 0.17 is non-standard. That is
To
such
what degree?
a simple concept. I don't
Yeah, it is a simple
understand
concept,
how
but it
you
means
can't
nothing.
comprehend
Paul,
it.
it's like the baby. Somebody gave the baby example last night where the baby had a temperature variation of plus 0.1 degrees, right? And it was technically above normal, but it wasn't that much above
That's
normal to
right.
make any problem. So
Yeah,
what
but
we're
I
asking
think,
for
Anthony,
is,
plus 18 is a little bit above 0.17.
but what's the effect, Paul? Is it huge or is it minuscule?
0. How much bigger is 1 than 0.17, Anthony?
It's not what he asked. He didn't ask how big the difference in numeracy
many
was. He said,
times-
how much is the
how
effect?
many times-
How much does the effect
How many times
differ?
bigger is 1 than 0.17?
We can do basic
Nathan?
maths, Paul. He's just asked you what the effect is, and you're going back to the maths. You do this every time he asks you for evidence. You do it every time I
Right.
ask you
The
to evidence this refraction in the image.
effect of
You
the
start asking us
non-standard
about how maths
refraction
works.
The effect of the non-standard refraction is that it makes the light bend more.
Yeah, but Paul, the bit that you're not doing very well is putting it into context for us so that we understand the values between 1 and 18 having a massive effect. So what you're saying may well be true, but we're stupid and we're asking you to tell us how it show us how it affects
So you're
it.
now ready to get an explanation. Good. Okay. A standard refraction
not an explanation.
value
A
of
visual
0.17
demonstration. A visual
we want
demonstration,
to see
Paul.
the band of refraction and show where this falls into non-standard over standard refraction. Because I'm asking you, because we're stupid, I'm asking you, what do these numbers mean? Now, I'm not asking you to explain it. I'm asking you to prove it. There is a big difference, Paul.
Well, shall we do some calculations yet again?
No, Paul.
We're not
no.
doing calculations. I want to know what the band of figures that you're citing
Then how
is.
can I prove it? How can I prove? How can I prove
With
how
evidence,
these values
Paul.
have an effect on the refraction if you won't allow me to do the calculations?
Show us a graph where the coefficients from whatever value to whatever value indicate normal refraction and then non-normal refraction, so that it makes it easy for us without having to do maths. We want the conclusions, but it can't be your conclusions. It has to be the conclusions, so we can quantify where these values fit.
Anthony, why
Paul.
do I have to prove to you that anything other than anything other than 0.17 is non-standard?
All right, Paul.
This is ridiculous, Anthony.
No, Paul, it's not
Everything
ridiculous.
other
You're trying to
than
show that
0.17
non-standard
is
refraction is a thing. And I'm asking
non-standard.
you to put it into context. If you can't put it into context, it's
Okay.
meaningless, Paul. We're stupid, remember? We don't know. So what we're asking is, show us where the divide from standard to non-standard falls in a form that's not Paul. We want to see it from a neutral position.
Could I just ask a question, Paul?
Yes.
Yes, Paul. You know this study that you're referring to here. Would you be able to tell us when this was actually taken? I mean, what month, please, and what the temperature was?
Yes, I can go up to the. I can go up to the top. I can go up to the top. You can look up the references in this. I'll actually put a link to this article in the side chat, Ranty, and you can read the entire thing yourself, and you can go and look up the references that they refer to for the studies of when these measurements and who took these measurements. You can do that if you like.
But the point we get to, Paul, is what do the numbers mean? What's the net effect of the numbers?
Hey, excuse me, Ranted Riley. Hello, hi, I'm Josh. I'm new to this thing. I've been here once before, but I'm just wondering, why haven't you guys ever tried to collaborate and actually take add single observation of something from two different locations at the same time, or actually take accurate measurements of your observations when you're taking?
Josh, we did do that, and do you know what we found? Ranty was able to pretty much see where I was, but couldn't identify me. But I couldn't see him at all because I had this refraction, huge amount of mirage in front of me, stopping me from seeing him completely. So we have tried to do that.
Sorry, Anthony. That's hi, I'm Josh. We haven't spoke before, but that's sort of what I'm asking. Is why, you could. There's this weird flat Earth thing where you have to take like an observation by yourself and no one can have anything to do with it and no one can know anything about how you took the observation. Why haven't you guys tried to like be in different spots on the coast and take a photo of something and zoom into something and like why haven't you actually tried to be scientific about this? That's my question.
We have done, Josh. We've observed Blackpool Tower from 4 different points up and down the coast and got the same effect, no curve.
No, at the same time.
Well, no, because you can't be omnipotent, can you? Be reasonable.
No, you can. That's the wonderful thing about these days. It's what we're doing right now. I am in Australia. I am in Melbourne, Australia, and I'm talking to you, and you are in somewhere the UK. That's,
yeah, but you
that's
can't be in New
incredible.
Zealand as
If
well
you
as
want
Melbourne,
to call
can
that
you?
omnipotence, good all power to you. But right now, we can take observations that are like happening at the same time. And you guys could do that with your P900s and try and take photos of identical features and do things. Like, do you not see that that's a bigger, broader, more expansive experiment than one single photo?
Yeah, but again, though, you can't be in 3 or 4 places at once, can you? You would need 3 or 4 people, and there's only 2 of us.
I'm so sorry, Anthony. I'm hearing you doing that thing that I've heard you do, but I'm saying you and Branty, or you and another one of your flat Earth friends, or some other people, you can all get together. You could all join a hangout, and you could all take an observation at exactly the same time. You could literally go 3, 2, 1. Everyone click. And everyone click and takes the photo, and then you can examine the evidence.
I've done that, Josh.
Why
Josh,
haven't you taken that step?
What benefit would that do, though, to help?
I've done that, Josh. So we had live hangouts running for 24 hours solid, which were hosted by me and several others, where we had people tune in with their solar noon, sunset, and sunrise simultaneously, live.
Now, Nathan, look, I don't want to disparage, but I have heard of this. But I've also heard you say people need to trawl through a 4 or 5 hour hangout just to see results and things. Do you have a little like 5-minute clip that you publish to the world of bam, this is what we got?
Nope.
Well, in the multiple purpose, no. But in the, what difference does it make? How does it make it any better if we do?
Is that really a question? Do you not think that multiple people taking multiple observations at the same time is not better than a single one?
I have.
Well,
I've just thinking
of,
you, Josh,
for example, but
that.
not specifically. Soundly doesn't get the same expectation of him, so why would you do it of us?
But I've just said that I have done that, and now why haven't you condensed that down to a digestible format? I don't really understand what you're doing, Josh.
We all believe that the world is a globe. You're trying to disprove it, so you're the ones that need the big hit. You're the guys that need the big king roundhouse double lee kick whammy thing. You're the guys that need that.
Josh, he who asserts has to prove, and the assertion lies with the ballers. It's not satisfactory, the evidence to support it, that we live on a ball, hence why flat Earth even exists. So when we go out and do observations, we're finding anomalies.
One that's asserting that it's flat.
No, we're asserting that your ball model does not do what you think your ball model does.
Therefore, you have to prove that it doesn't do what you think it does.
Well, we are, and you're arguing it's non-standard
that
refraction.
We think it does. Every single observation is predicted well in advance, and it happens well in advance, and we know exactly what's going to happen next.
Josh, do us a favour, just turn your camera off. It feels like I'm talking to Knight Rider.
Look, I've actually just got a little bit of red tape on my camera. I'm sorry about that. I'm a bit of a conspiracy nut.
Just press the button to turn it off at the top of the screen. Just press the button off at the top of the screen. It just knocks it off because it feels like I'm talking to the dashboard of Knight Rider when you speak.
I'm sorry, I don't know how to do that. I'm just on my phone. I've hit the button there. I can turn the camera around. Is that better?
I don't know. Nathan, can you not knock it? Yeah, that's better. It's gone black now.
Don't worry about it.
Yeah, black's better. So I guess my big question as well is why don't you guys try and take an observation Like, you're talking for weeks now about this refraction and stuff that's happening off this little bit of land over there. Why don't you just extend that further and go to the stars? Why don't you take a photo of a star coming up over the horizon and seeing whether or not a guy that's behind you, like 100 miles behind you, could also see that star?
How you doing,
Tell
mate?
me,
Four?
how would that prove or help prove the shape of the Earth?
How you doing, mate? Four? Good to have you.
Well, because if
I guess
a guy
Anthony,
100
you
miles
could see it,
behind
but
you,
he couldn't.
Yeah, but that's
Yes,
do
yeah,
you not
exactly.
understand that
Say
that
it,
would equally
Anthony.
be explained by convergence?
If you could see it, Anthony, and he couldn't, well, then there would be no reason for that.
But again, it's
flat
back to
Earth.
my former point: as why is this flat Earth thing so singular? Why is it there's only one photo, and let's all just blur this one photo? What, like, there are 7 billion odd people on this planet. Why can't flat earthers at least have a team? Has anyone even heard of a team? And Nathan just said, "Oh yeah, I've got a team. I've got sun tracking." And I said,
because
"Could you condense it into
the minute anybody
like,
tries
is there a video
capitalising
that
out of
just
this,
says you're results?" Oh no, you're going to go through 5 hours of sun tracking nonsense to see the results. Like, come on, man. If you had
Anyway, we are coming up on approximately half an hour left on this stream, so I'm going to run through my last set of links and then leave you with half an hour of the action. So if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join the panel, simply click on the mute button on the page you are currently watching, then click the link in the info box below this video to join the show and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin using sock accounts. You'll be warmly welcome back on the next stream. If you've not done so already, please share the show, and one last time, if you are not subscribed, hit that subscribe button and the bell notification icon to keep up to date with the Flat Earth debate.
Someone on the other side of the world. All you have to have is someone far away in Australia.
Oh, bro, how do we do that?
You just phone someone up in another state, like Queensland, and you
shit,
get them
bro.
to do the observation with you, mate. For
Oh, what do we look how
Aren't we
we do
doing
it?
it right
they're on
now?
the same
Are there
time
like 3 Australians on this chat and about 3 English people on this chat? This is the world that is being connected right now. Yet not a single flat earther wants to try and use that and make a specific claim and try and test it. Since flat earth has been happening, we've had like an eclipse, a couple of equinoxes, and we're like, we're just crickets. No one's putting their hand up anywhere. Like, what is it with that? It doesn't, at least anyone find that suspicious?
A little bit. It's weird. And I am still tripping out about it. Like, it makes me second guess science, and that's sometimes I realize it's silly, and sometimes I realize, wow, science doesn't have an answer for those things. So it's like,
people tend to second guess science when they don't understand it. Riley's
Yeah,
a
for sure.
perfect example of that. He
Well,
doesn't
I don't wanna
understand how refraction works.
Oh no, I do,
Yeah,
Paul. I just
so he
realise
goes
that when
cool,
people are
like,
trying to blur the lines
maybe-
like you.
like, I have to say, I came in here not knowing shit, because some random dude that I met in China was like, the world's flat. And so I was like tripping out for like a few years, and then just looking at, not really tripping out, but like I was looking at YouTube videos, just always running my head in about thinking about what's going on. And finally I came in here, and yeah, I've told this, like, that, you know, like, I don't know, like, to me, I've already figured out that this, just from a little bit of help, like, that this, it does seem to show a globe model from the sky. And I don't know, like, what these pictures and stuff, we need something better that can really prove this stuff.
How much more do you want? A missing mile of curve? I mean, come on, that's pretty.
Well,
pretty
I
persuasive.
agree, Riley. Like, yeah, fair enough. And it's weird, like, you know, even the fact that you can see Isle of Man and that it should be curving off down the back left side or whatever that is as well. Like, I think it's weird that you don't see islands, or sorry, like land do that. Like when you're on a beach and you're looking at the next little bit of bay section that sticks out on the very far other end of the beach, like that section should be sort of like curving off as well. And I mean, is it just so massive we don't notice? We seriously, like, I kind of agree with this random Aussie dude that came in and was like, we need something better than this, and then just poking each other with sticks and like saying, "Oh, this
we just need evidence. That's all.
Pretty much,
We
but
don't need anything more than evidence. What happens when you get the evidence is people then start skewing the evidence and putting numbers where numbers don't belong, and then becomes confusing, and then people just revert back to the ball, which is exactly what Paul's intention is.
Like, personally, I think, man, like, how does there's so many weird ideas that we have to try and like get our minds over. Just even the vacuum alone, like the fact that gravity can hold a vacuum somehow magically, I don't know, and the gases stay here with us.
It's not magic, mate. There's nothing magic about it.
Well, I don't know, man. Like, gases are pretty like.
If you think it's magic, then you don't. Then you've got a lack of understanding.
Well, it sounds like magic the way you're describing it, Paul.
Like, if there's such an infinite
understanding. If you think it's magic, then you have no understanding of what's really happening. Simple as that.
No, people don't want to hear what Make 4's got to say.
Hey, Anthony, would you not think that at least the very next time that you go out and take a photo of something, that you should get all the GPS coordinates available, and like I say, have a buddy, have a mate,
sure, yeah,
have someone
again
another 10 miles down the coast and take a photo at the same direction at the same time, like verification. Do you not think that would be the better way to go about this thing?
Right, again, for the benefit of just you, because you've obviously not been watching, when I went up to do that observation, I wasn't doing that observation. I went up to see if I could see Blackpool Tower. That was it. Couldn't see it. It's too far away. It's too small. However, whilst I was up there, I just recorded what I could see. Maybe 2 months later, ranty spots that it's not the same as what we should be seeing. So that's the only reason why it was a bit skew with, because I didn't go up there with the intention of doing that particular job. I only documented what I saw when I was there.
Yeah, but that's not science, right? Science. The whole point of science is you come up with an idea and then you try and test it.
I've just
that's
agreed
what science
dude,
is.
I've just
come up with an idea. You don't just take a photo and then just go blah about it for like 3 weeks and have people going blah about it for 3 weeks. You're
just following me now, aren't you? You're not listening to what I'm saying.
You wanted to take it. So what are you doing?
You're not listening to what I'm saying, are you? Can we go back to the magic maths that Paul was talking about?
I'm not sure if he's still here.
Sure.
Oh, he is. Good.
Right. So, Paul, with these numbers that we were talking about, I was asking you, how could you demonstrate to us, not with maths, but with actual evidence, with something credible that we can look at and say, right, these are the coefficients that's quoted in the paper that you've cited. Let's see what the effect is. I'm not asking you to do maths. I'm asking you to show us the context in which the plus 17 variation on the coefficient over water, what the effect is. Can you show us something that puts it into context? If you need time, fine. But you've got to. I'm not being funny, Paul. We're stupid ball earthers that don't understand, flat earthers that don't understand science, right?
You're not being funny. All right. I know you're not being funny, but there are certainly images. Are you sharing my screen at the moment? Okay.
Yes.
Let me see.
There you go. That looks like it might be it.
We have. These are the instruments they use to measure this in the paper. This is not actually examples of what happens, but there is another paper that shows. All I'm saying is the paper that I've put the link into the side chat, people can go and read that paper if they like, and they can see the references and go and verify that people have actually measured these refraction coefficients. They're not something that's just made up. People have actually measured them.
Are there any visual demonstrations of the effects they were measuring, Paul?
Yep. Okay. So the effects of those sort of things. I've just got to find the right paper. I know that there's one. Okay, here's some effects. Okay.
What here we go.
See here.
Excellent.
All right. All right. Are some effects.
Are these really comparable to what we're looking at in comparing to, Paul?
What's that?
So we've got some crazy stuff going
now, I
on in
don't
these
know
images,
what-
Paul.
Yeah, you have got some crazy stuff going on there. I don't know what refraction coefficient they have for these images, though. Okay.
So it turns out
I
a
don't
lot
know.
more crazy refraction stuff happens on the ground than in the sky, and that's why flat earthers refuse to look at the sky. Is that what's happening?
So maybe if you can see my screen,
much.
Paul, we've just seen a few effects of this
Hang on.
non-standard refraction. Maybe if we just pick an arbitrary point on this image, maybe you can tell me where those effects are starting or where they're ending, where we have clear line of sight.
Well, that is a ridiculous question, Nathan.
Well, you
because
just
they
said that
don't
we're seeing
start or
non-standard
stop
refraction, Paul. So if you can
anywhere.
evidence some of that
No,
non-standard
no, it
refraction in
doesn't-
this
no,
image, I'll be very grateful.
Nathan, that's a straw man argument. It does not start or stop anywhere.
But the thing is, though,
image.
Paul, you're calling it a straw man
That's a
argument, but
straw
we're
man.
saying it is the argument.
It is the
It's
argument,
a straw
Paul.
man because it doesn't start or stop anywhere. The
So we can't
whole
see it?
image
Well,
is
affected.
Hold on, I just want
it
Paul
starts right at the
to
point
say
where
that
the
we
light
can't
gets
see it,
reflected
so we
and
can't
it
see any of
stops
the
at your
effects.
eyeball. Isn't that what's
Can we,
happening?
Paul? Can we or can we not see any of the effects of this non-standard refraction, or not? Can we see those effects in this image? Yes or no?
You cannot determine how much has been refracted unless you know the real height that something should be and you
No,
measure
unless
the
you know the
observed height.
variables.
Then you can calculate the effects of the refraction, Nathan.
That didn't answer
you
my
cannot
question.
tell
Can I
how
ask you
much
my
has
question
been
again, Paul? I
refracted
don't think you
simply
heard it.
by
I think you were just
looking
talking
at
over me
the
as I asked
image.
it.
That
Can I
is a
ask it again, Paul?
ridiculous
Paul,
thing
can I ask
to
you?
ask
I didn't.
for.
You didn't answer my question, so I'll assume you didn't hear it. Right. So, can you
No,
ever?
I did hear it, Anthony. I did hear it, Nathan, and it was ridiculous. You cannot determine how much refraction you are seeing by simply looking at.
Right. Can you actually show that there is any happening in this image, like there was on the images that
the
you just
refraction.
showed? Can you?
You
You've shown
cannot
us.
determine how much refraction has been occurred by
So
looking
why are you trying to
at the
calculate
image.
for it when you don't know?
So if we don't know it's there, why are we calculating for it?
What? No,
If we don't know it is there,
that's not what I said.
why are we calculating for it if we don't know it's there?
What do you mean you don't know it's there?
That's not what he
How
said.
do you?
That's
Okay.
not-
How do you know? How
Well.
do you know it is there, Paul?
Well, we know it's there, Nathan, because according to the standard refraction model, part of the lighthouse should be hidden below the curvature.
But it
The
isn't.
fact that we see, yes, that's right. The fact that we see it indicates that we are seeing non-standard refraction. And we
No, it
could
just
actually
indicates that we can see
calculate
it.
how much
Why?
that
Okay, hold on,
refraction
Paul.
is by
Why
knowing
would we
what
need?
the
Why would it
apparent
need to
height
be
is
refracted?
and what
Why
the
can't we
observed
just
height
see
should
it,
be?
Paul? Why can't we just see it?
What?
Why can't we just see it? What's wrong with just saying we can just see it?
Why can't we just see it?
Yeah, why can't we?
Well,
We can.
why
Let me
can't
just phrase it to you, Paul, without you interrupting. We can just see it. We see the lighthouse, for
No,
example.
I'll interrupt as much as I like, Nathan, because that's what you do.
Okay, feel free. We see the lighthouse. What's wrong with just saying that we can see the lighthouse?
What's wrong with saying we can see the lighthouse because of refraction?
Because you can't prove the refraction.
Because you've just said that there are no effects of it that we can visually pick out to say that there is refraction occurring. So it's like the Emperor's New Clothes.
That's
We
right.
just have to accept that it's happening because you say it is.
Exactly.
We
Exactly.
accept
That's
that it's
exactly it.
happening because according to our model, the known radius of the Earth, we should have part of the lighthouse hidden below the curvature. The very
Yeah, according
fact
to
that
your
we
model.
Thank you.
see
Thank you,
If your
Paul.
model's wrong.
the lighthouse
No need to
means-
interrupt. Thank you for saying that, Paul. So essentially, because of the presupposition that we live on a globe, it necessitates us having refraction.
Yeah.
What about the
That's not what he
presupposition that we live on a flat Earth?
No,
Because
we have a
if we
photo that
presuppose
shows
we
us
live
living on a flat
Nathan,
Earth, Paul.
We should see the
We have
entire
no
island of the
presuppositions.
island.
When I say
And
something
we
about this photo,
don't,
Paul, I make it very
do we?
simple. We see the lighthouse because it's there. It's simple. There's no
And
other
I'll make it
effects
very
I need to
simple,
explain or
too.
apologise for
Don't
at
see
all.
of the cliff,
You
even
have
though
to
we know it's
apologise
there.
because of your presupposition that we live on a sphere. I have to make no apologies whatsoever.
your
We see the
presupposition
lighthouse
that we live on a
because
flat
it is
Earth
there,
should
because we
indicate
have
that we should see
line of
all
sight.
the island, Nathan.
We have
But
line
we
of
don't,
sight
do we?
because we see it.
We don't see
Paul,
all of
let
it.
me
Yeah,
ask you this.
and we
Paul.
don't see all of the cliff, do we? We don't see
Paul.
all of the cliff, Nathan.
Okay, let's
even
go
though
through
we
this
know
argument
the
then, Paul.
cliff is
How much? Hold on. How
190
much?
feet
How
high.
much below the lighthouse do you suggest is missing?
150 feet.
150 feet. That's very interesting, Paul.
We don't see it, do we, Nathan?
Hold on.
Don't we see it?
Okay. No, let's just, for the sake of argument, concede that. Let's just say that.
Oh, we should see it all.
Okay, Paul. I'm going to
But we
concede
don't
for
see
the
it all.
sake of
Even though
argument.
we
I don't want
know
any
it's
comments.
there, Nathan.
You know, you've got verbal diarrhea,
We
Paul.
don't see it, even though we know it's there.
You've got verbal diarrhea, Paul. You've got verbal diarrhea, it would seem. So, for the sake of argument, you've got. Let me get 3 words in. You're just a bit triggered, it seems. So, for the sake of argument, we will concede that there is a. We will concede that there is 150 feet missing for the sake of this argument. So you're saying that 150 feet is obscured by curvature for some reason at the bottom of this island. Right. So, if that is the case...
We know that
hold on, Paul. Bear with me, Paul. I know you're very triggered. I know you can't be patient enough to get to my end of my question, but I'm going to do it anyway.
Yeah, we've been there before, haven't we?
How high is this land at the end of the Isle of Man, Paul?
Well, we need to determine what that land actually is in the first place, Nathan.
I've conceded for the sake of this argument, Paul, that the lighthouse is conceded. Hold on, Paul. Paul, I know you're very triggered. Just try, Paul. Take a breath. Count to 10. Count to 10, Paul.
No.
Just count to 10.
There you go.
Take
a
little breath.
Taken. Now I'll continue talking.
Take a breath.
Gem Panda showed that the very end of the island that we can see is actually Douglas, and we can't actually see Douglas. That we're not seeing to the very left-hand side of the Isle of Man.
Yeah.
Are we?
So for the sake of this example, Paul, I will concede that we are missing 150 feet if you will concede that this is the left tip of the Isle of Man. Otherwise, we have no argument here.
Because I don't believe that it is the left
what
tip
is it,
of the Isle of Man. You don't get to
you
make me
believe
accept that.
You think it's Douglas?
I don't accept that.
You think it's Douglas, this?
Well, I can't see what you're seeing.
Yeah.
There's nothing on my screen.
Bear with me. Sorry.
Surely, to even talk about this, you guys would need at least 2 photos from 2 separate locations taking the same event.
Well, that's not required when it comes to Soundly, is it? So, no.
Why is that your yardstick? Aren't you doing this yardstick for yourself? For the future? For Flat Earth? Why wouldn't you do this so that you can provide the knockout punch, the knockout KO to the world of the globe? Wouldn't you want to come forward with something good and something irrefutable?
This is
I can see, Nathan, that we're going back to the poorly constructed composite of Ranty there that's got repeated bits in it. That's what I saw.
If I've bought the wrong one, my apologies.
Which is what I'm saying, Paul. As wouldn't they want to at least have 2? At least, like, well, what's better than 1? 2. At least 2 photos to go off. Like, what do you even do?
Don't worry, dude. Then the other photos are coming. Don't worry. Relax.
It'll be interesting to see what they say if you get like 5 photos in a row and it's exactly the same every time. Is it non-standard refraction?
That would be, but to be honest, I would need a shed load of photos because
but Anthony, it just seems that knowing you, they're just going to be the same ridiculous photos from a no-nonsense point, and you're going to have no information as to where you were and your altitude and your distance and the temperature and all that.
We'll give you 100 feet, dude. You need 1,000 feet. I actually heard
the hangout when you said, "Oh yeah, it was 30 degrees," and Paul said, "You haven't had a 30-degree day ever. It was 13." Come on, man. That's just not a mistake. That's ridiculous. The difference between knowing what a 13-degree day is and a 30-degree day is shorts, t-shirts, scarves, and like
yeah, but
you
dude,
know that difference.
I've been there
that
twice,
was just
dude,
another one of your blatant lies.
The second time it was cooler. I'd forgot which way round it was. It isn't a big deal, so it doesn't change the evidence.
Did you forget what 13 or 31 was?
Dude, I made a simple mistake. It was corrected and it's moved on from. It's not a big deal. So dance around it as much as you want. It still doesn't change the evidence that you're looking at.
And with that, I'm going to say, first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and sharing this show. And of course, a massive thank you to all of the live panel for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I'll see you all in the next video.